All right, so you made it through the first exam. Today we're going to pick up on chapter 4, which deals with using the rectangular coordinate system. Okay, so the things that we're going to go over today, we're going to learn how to plot points. We're going to learn how to verify solutions to an equation containing two different variables. We're going to complete a table. It's pretty easy stuff so far. And then the last one is just going to be finding solutions to a linear equation in two variables. Okay? So first, let's go over a rectangular coordinate system. Now you're going to be now you should notice on your screen that I'm using graph paper, grid paper. All right, and it's really going to help us out by using this because it keeps everything nice and neat. Okay, so in Math 80, and to be honest with you, all the way up till this point right now, you've always been focused on just a basic number line, okay? And this number line always started right in the middle at 0, and to the right were positive values. Boy, it'd help it if I can count. And then to the left were negative values, okay? So this should look very, very, very familiar. And a lot of the times when we were looking at, linear equations, we were always trying to solve for x. So we would call this the x-axis. Today, we're going to introduce another axis, and that axis actually goes up and down, and it meets, or it intersects at 0, and this point right here, right in the middle, all right, where the 0 is, has a very special name. It's called the origin. It's where everything starts, okay? So if you notice, by me introducing this new axis, and it has a name, it's called the y-axis, anything above the x-axis are going to be positive values, and then anything below it will be negative values. Now, what I've done is I've created 4 quadrants, okay? So this is quadrant 1 in the upper right hand corner. It's called quadrant 1. And what's really interesting about this is that when we go ahead and plot a point, let's say we plot this point right here. This is called the point 3, 2. All points will always have 2 things in common. First, it'll have the x-coordinate listed first, and then the second number listed is called the y-coordinate. And when you have a point with the name 3, 2, we call that, and I'm going to break out a new color here, we call that an ordered pair. Meaning, ordered, x comes first, y comes second, pair, 2 numbers, and they're always together, okay? Now, earlier I made the comment that this first quadrant has something special, and that is the fact that all ordered pairs within the first quadrant will always be 2 positive values. X will be positive and y will be positive, okay? Now, quadrant 2 is to the left. There's quadrant 2. And in this quadrant, And I'm just going to go ahead and plot a point. I'm going to call this -2, 3. You will notice that in this quadrant, all the x coordinates will be negative, but all your y coordinates will be positive. Okay? Now, some of you may be sitting there asking, well, how did he label -2, 3? Like, why did I do that? Well, if you picture yourself standing at the origin, remember I said that's where all things start, and I asked you, how do you get to the ordered pair -2, 3? What you would say is, well, you start at the origin, and you're going to walk 2 units to the left in the x direction, hence the order, very important. And then you're going to make a right-hand turn, and you're going to walk up 3 units in the positive y direction. And that's how I arrived at that point, -2, 3. Think about it in terms of like giving somebody directions. If you asked, where's Target? And the person goes, up the hill to the right. That's pretty descriptive. I mean, you got to go up a hill, and then you're going to make a right-hand turn. However, if someone says, or if you ask somebody, hey, where's Target? And they just say, over there, I would just walk away. I would just drive away, because you're not going to get anything else out of that person. So it's always nice to be very descriptive. In this case, when we talk about points, it's really an ordered pair. X comes first, Y comes second. So now, let me show you where the third quadrant is. The third quadrant is down here, lower left-hand corner of your screen. All the points here, the X and Y coordinates will always be negative. They're both negative. And then the fourth quadrant is lower right. And all the points here will always have a positive X value and then a negative Y value. And remember, the most important point is the origin. It's right in the middle. And that's where everything starts. Okay? What makes this kind of difficult, I'm going to be honest with you, is when you're just sloppy at writing. And trust me, that is me 100%. That is why I always use this graph paper that I have on my computer. It just helps out tremendously. If you want some graph paper, obviously you can always go purchase some. What I would do is probably just go to the Google machine, type in graph paper, print one sheet, and then go to I don't know, maybe CCAC and use their copiers for free. Or just go to CCAC, go to the library, or not the library, one of the computer labs, I guess, and do the same thing. Google graph paper and print yourself up like 20 or 30 pages. Keep it simple. Keep it cheap. Good? All right. So what I want to do real quick is just give an example here. So let me go ahead and draw my rectangular coordinate system. We label some things real quick. 1, 2, 3, 4. -1, -2, -3. 1, 2, and I'll extend this down a little bit. -1, -2. And all I want us to do is just label the ordered pairs. Label the ordered pairs. So if you want to, go ahead, pause the video. Label what A is, what B is, what C, D, and E are respectively, and then you can unpause it to see if you're correct. But what I'm going to do right now is I'm just going to go ahead and just start labeling them. So point A is going to be 2, 1. And that's because I started at the origin, I went 2 units to the right, and 1 unit up. Okay? So that's the first one. Now I'm just going to speed up a little bit. B is going to be 4, 2. Point C is going to be 2, -2. Oh, D is going to be -2, 1. And then point E, the last point, is going to be -3, -2. Remember, ordered pair. Order matters here. X comes first, Y comes second. All right. Now, there's one thing that I've been kind of tossing around, and hopefully you're already thinking about this, and that's the word linear equation in two variables. Now, we've studied linear equations in Chapter 2, Chapter 3, and even back in Math 80 if you took Math 80. So recall 3x plus 1 equals 7 is a linear equation in one variable. All right, now you need to ask yourself, why is it linear? And it's linear because the variable x is raised to the first power. That's what makes it linear. So, if I am using the language, let me scroll up here a little bit. If I'm using the language, a linear equation in two variables, well, hopefully you're sitting there thinking to yourself, okay, he's going to be using two different variables and they're both going to be raised to the first power. And that's exactly what a linear equation in two variables is. The most general form is this. So an equation of the form ax plus by equals c, where a, b, and c are not. I'm gonna say it like this: a, b, and c are constants. You know what? Let's keep it even simpler. Are numbers. We'll just call them numbers. And a and b are not both 0. Is called a linear equation in two variables. All right? The most easy one I can give you is just this one. How about 2x plus y equals 5? That is an example of a linear equation in two variables. Note, both the x and the y are raised to the first power. That's what makes it linear. In this situation, a equals 2, b equals 1, and c equals 5. And all I'm really doing here is I'm just matching it up. And that's honestly what a lot of math is. It's like kind of like matching something up. It's looking at a problem that you've never seen before and then trying to match it up to something that you know. Okay? Now, there is something special about this ax plus by equals c thing, okay? Whenever both variables are on the same side, so I'm going to put a star to the right. I'm going to put note. Actually, just put note both variables are on the same side of the equal sign. When that happens, we say that the equation, the linear equation, is in standard form. Okay? So when both variables are on the same side, it's called standard form. Okay? Now, sometimes you want your equation in standard form, sometimes you don't. That's one of the most beautiful things about mathematics, and it's also one of the more frustrating things, is because there is no right or wrong answer. It's just, what do you want it to look like? If you want to write in cursive, then write in cursive. If you want to print, write in print. If you want it in standard form, you better get both variables on the same side. All right? So let me show you an example. Convert y equals negative 2x plus 7 to standard form. All right? Well, we know, and I'm just rewriting the problem here real quick. we know standard form means both variables have to be on the same side. Currently, the negative 2x is on the right-hand side with the constant c. We don't want it over there. We want it to be on the left-hand side with the letter y. So what are we going to do? Well, since it's negative 2x, we're just going to add 2x to both sides of our equation. All right? And that is going to allow us to put this into standard form. So we get 2x plus y equals positive 7. And now this is standard form. Okay, so now what I want to show you is how do we actually determine whether or not an ordered pair is a solution to the equation. So if I were to scroll up really quick, okay, we already plotted points. We went over standard form. So now what we're going to do is we're going to turn our attention to verifying solutions to an equation containing two different variables, okay? So one thing we got to remember is, and this is going to sound crazy. Once I say it, you're going to sit there and go, oh, how am I supposed to do this? But it's actually, once you see it in action, it's really simple. Linear equations in two variables have infinitely many solutions. Okay? So let me show you what I mean by this with a picture. All right? Because I got to be honest with you, your book kind of goes into this, but I think if they showed a picture, it would be a lot easier to understand. All right? So let me show you something. I'm going to draw this. Okay, and here's a line right here. The name of this line is negative x plus y equals 1. Now, if I could take a point and plot it on this line, such as that point right there, this ordered pair, and that is the ordered pair 0, 1, that is a solution to this equation in standard form that we have above. If you think about it, if I were just to take my ordered pair and substitute it in, now remember, I like to rewrite it wherever I see the variables, I put parentheses, and then what I'm going to do is substitute in x equals 0 and y equals 1, and all I'm going to do is simplify. Well, negative 0 plus 1 is just 1, and 1 equals 1. Notice this is a solution to negative x plus y equals 1. So note that the point 0, 1 is a solution to the linear equation in two variables, negative x plus y equals 1. Well, it just so happens, okay, and I'm going to erase some stuff here. It just so happens that if you pick any point on this line, let's say this point right here, which this is going to be the point. Let me just catch up. So it looks like this point is 2, 3. If I were to substitute that in, so directly underneath, let's make our substitutions. Wherever I see an x, I put a 2. Wherever I see a y, I put a 3. Recall that negative 2 plus 3 definitely equals 1. So this point is also a solution to the equation negative x plus y equals 1. That's why we say, and I'm going to scroll down a little bit, that's why we say linear equations in two variables can have infinitely many solutions. And the reason for that is this line you'll notice on the bottom left and top right has those arrows, which means it keeps going on forever and ever and ever. So as long as the point falls on this line, no matter where it falls on the line, it will always be a solution to negative x plus y equals 1. Now I think I should show you a point that is not on this line and show you how it fails. So let's pick the point, and I'm going to use a completely different color here. So we'll use green. Let's pick this point right here, 1, 1. When I go ahead and make my substitutions here, x equals 1 and y equals 1, negative 1 plus 1 equals 0. Now, 0 does not equal 1. And that's exactly what we would expect because this point, 1, 1, is not on the line. Therefore, it's not a solution. So not only visually can we see that it's not a solution, but now algebraically, we also verified that it's not a solution either. So now that we kind of have an idea, okay, I'm just going to give us an example, and we're just going to determine whether or not these ordered pairs are solutions. So here's an example. Determine whether the ordered pairs are solutions to the following equation. So we're going to do two examples here. All right, so here's our first one. Negative 5x plus y equals negative 1. And the ordered pairs that I want you to examine are going to be 0, negative 1, 1, 4, and negative 2, negative 7. So what's really nice about this is if you want to, pause the video, come up with your 3 solutions, and then unpause the video and see if you're correct. What I'm going to do is I'm going to go right into it, and I'm just going to be erasing, so make sure that you're following along. The nice part, like I said, this is a video, so you can always just pause and go back. So I'm going to rewrite my equation to the right, except I'm going to put parentheses wherever I see the variables, and then I'm going to make my substitutions. So for part 1, x is 0, y is negative 1. So when I simplify, negative 5 times 0 is 0, plus a negative 1 is minus 1, and 0 minus 1 is negative 1, and that does not equal positive 1, which is what we would expect to get. So for the first one, no. 0, negative 1 is not a solution to the equation negative 5x plus y equals 1. So let's try the second point now. So I'm just going to erase. You know what? I'm going to use a different color. So I substitute in x equals 1, y equals 4. Now I simplify. Negative 5 times 1 is negative 5 plus 4. And negative 5 plus 4 is negative 1. And that does not equal negative 1. So no, that is not a solution to the equation. And then lastly, let's do our last point. Negative 2 in for x. Substitute negative 7 in for y. So we have negative 5 times negative 2, which is positive 10. Now we have a plus negative 7, so we're going to rewrite that as 10 minus 7. Now, 10 minus 7 is 3, and 3 does not equal 1. So negative 7 is not a solution. I'm sorry, negative 2, negative 7 is not a solution. So none of these were solutions. And that's okay. That's okay. Okay, next example. Directions are going to be the same. Okay? So let's see here. Actually, I'll change up the directions because they word them differently. Which of the following ordered pairs are solutions to the equation y equals 4x minus 3. So first pair, 0, 3. Second pair, 1, comma 1. Third pair, -1, comma -1. Now notice our equation is not in standard form. That's fine. Like I said, there is no right or wrong when you're writing equations or linear equations to two variables. Pay attention to the directions, see what they want it in. But other than that, I mean, there's no right or wrong. You write it however you want, unless the problem wants you to write it a specific way. So what I'm going to do, let's rewrite the linear equation directly underneath. I put my parentheses, and we'll go ahead and make our substitutions. The only thing is you've got to be careful, because remember, this is y equals 4 times x minus 3. So for part A, substitute in a 3 for y, substitute a 0 in for x. So we get 3 on the left-hand side. On the right-hand side, 4 times 0 is 0 minus 3 is -3. These are not the same. So no, that point is not a solution. Okay, I'm going to erase. We're going to try the second point. 1, comma 1. So on the left-hand side, I get a 1. On the right-hand side, I'm going to get 4 minus 3. And if we subtract 4 minus 3, notice that we get 1 equals 1. And that is a great thing. So yes. Put a little smiley face. Okay? Yes, 1, comma 1 is a solution. And then the last value, the last point, substitute -1 in for y and -1 in for x. On the left-hand side, we get -1. But on the right-hand side, we get -4 minus 3. And -4 minus 3, recall, is going to be -7. Those are not equal to each other, so no. -1, comma -1 is not a solution to the point, or to the equation y equals 4x minus 3. So I hope that clarifies the statement that linear equations of two variables can have infinitely many solutions, and it's because if it's a point on the line, it's going to be a solution. Otherwise, it is not. All right, so let's move on to the next topic, which is completing a table. Now this, honestly, is not difficult at all. It is... Students always say plug in, and I hate when they say plug in because you plug in a lamp. In math, we substitute. So what we're going to be doing is we're going to be creating a table, and we're going to be finding ordered pairs. If you've noticed, everything that I've given you so far, like if I scroll up here and you look at all the examples, even in your notes, I've always gave you the ordered pair, and I said, hey, is this a solution or not? Or, graph this ordered pair on the rectangular coordinate system. Notice I always gave you the ordered pair, though. When we complete a table, what we're trying to do is find the ordered pairs. So, for example, y equals 2x plus 3. If I ask you to complete a table, chances are what I'm going to do is I'm going to give you some x values, okay? So let's do -2, 0, and +2. And I'm just making these x values up. I literally just made them up. What I want you to do is tell me what y equals, and then I'd like you to label the ordered pair. So for this first example, what I'm going to do is rewrite the problem. Wherever I see the variable x, I'm going to put a parenthesis. Notice I didn't do that for y, and that's because I don't know what y is. I'm trying to find that. But what I'm going to do is take my first x value, which is -2, and substitute it in. And what we're going to find is that when x equals -2, y is going to equal -4 plus 3, and -4 plus 3 is -1. So when x equals -2, y equals -1, and the point is -2, comma, -1. And that's as hard as it gets. That's legitimately as hard as it gets. So let's finish this table. So for the next value, I'm going to erase. My next value is x. So when x equals 0, y is going to equal 2 times 0, which is 0 plus 3, or just y equals 3, which means we have the ordered pair 0, comma 3. Okay? For the last one, we're going to do the same exact thing. Okay? We substitute into 2 for x. So when x equals 2, y is going to equal 2 times 2. All right, sorry about that. I completely lost train of thought. So when x equals 2, y equals 2 times 2, which is 4, plus 3. And y equals 4 plus 3, which is 7. So this is going to be the ordered pair, 2, comma 7. So now, here is the great part about this. And I'm going to show you something that I think we should all use. We should learn how to use it. And that's a graphing utility. So what I'm going to do is I'm going to go over here to Firefox. You're going to see a little window pop up here. And I'm going to type in, let's see if I can zoom in here for a little bit. It's not going to let me right now, but that's okay. Here's the website we're going to go to, Desmos. So if you look in the upper left-hand corner of the screen, desmos.com. It's desmos.com. And this is a free graphing utility. You can download it on your phone or your tablet or even on your computer. And it is just absolutely fantastic, and it's super easy to use. So we're going to click on Graphing Calculator. So now it'll let me zoom in. So I'm going to go ahead and click on Graphing Calculator. And notice you get the XY chart. Or I'm sorry, not an XY chart. You get the rectangular coordinate grid on the right-hand side. And on the left-hand side here, where my cursor's blinking, you can go ahead and you can type in things. Now, what makes Desmos so powerful is that you can literally type in your equation the same way it looks. A lot of graphing calculators in the past cannot do that. So what we're going to do is we're just going to type in y equals 5x minus, well, what was our equation? I completely forgot it. Oh, I'm sorry, 2x plus 3. Oh, now it's going to open Spotify because I clicked on it by accident. Do you want to cancel? Yes, I want to cancel. So we're going to type in y equals 2x plus 3. And notice on the right-hand side, you get this red line, which is our line that we wanted to graph. Now, what's really cool about Desmos is on the left-hand side, directly underneath where we just typed in y equals 2x plus 3, if you click directly underneath it, another line pops up, and you can check yourself to make sure you're correct. Now, our first point that we came up with, and I have to click back so I can see it, is negative 2 comma negative 1. Now, if we are correct, if our math is correct, when I go ahead and type in the ordered pair, parenthesis, negative 2 comma negative 1, and hit end parenthesis, that point should be on our line. And if you look, it's labeled in blue, and directly underneath where you just typed in the point, if you just click on the label box, it will actually label the point for you, negative 2 comma negative 1, which is great because that's exactly what we would expect to find. That point is definitely on our line. So let's go ahead and let's type in another point just to make sure we're correct. So how about 2 comma 7? We'll do 2 comma 7. So parenthesis, 2 comma 7, and the parenthesis, and let's go ahead, let's label it. You can see it's in the upper right-hand corner. It's labeled in green. And you can always change the color of the points. What you do is you come over to where the colors are. So notice that my line is red. My first point is blue. My second point is green. If you were just to left click on the point and hold it in, a little window pops up. And then this you can change. You can make it black if you wanted. You could turn the label on and off. I mean, there's a bunch of little things you can do. All I do is I will just change it to black and call it a day. And I'll do that for the second one as well. So let's change it black. There you go. Now, off to the right-hand side, you have the plus and minus signs. Those are just zoom buttons. So you can zoom in, you can zoom out. And then as soon as you start messing around with the zoom, you see the little house? That is default zoom. So if you were to click that, It just takes you right back to the default zoom. And that's about it. I don't want to show you too much in Desmos right now, because it is so, I mean, the depth of what you could do with this is just crazy, and it's free, which is fantastic. So let's go back to our notes. So we completed the table. The excuse me. The only way that I can, I guess, kind of make this more difficult is I can give you something like this. So let's complete the table for y equals negative 5x minus 1. So here are some x values. This column is going to be our points. And the only way I can kind of make this a little bit more difficult is if I do something like this. So if you notice, what I've done is I've given you a couple x values, but I also gave you a y value. But if you think about what's really happening here, okay, if you think about what's really happening, it's actually quite simple. We have our line, y equals negative 5x minus 1. So if I want to find the first ordered pair, that x equals 0, what I'm going to do is I'm going to write y equals negative 5, parenthesis, minus 1, and then I'm going to make my substitution. So everything is the exact same. So when x is 0, y is going to equal 0 minus 1, or y equals negative 1. So my ordered pair is going to be 0, negative 1. Now, with this second value, I'm trying to throw you a curveball, but hopefully you're looking at this and you're going, well, that's really not a curveball, Professor, because all I'm going to do is, instead of writing the letter y, we're going to write parentheses negative 5 times x minus 1, because I'm telling you that y is negative 2. What I'm asking you to find is what's the x value. So for here, we get negative 2 equals negative 5 times x minus 1. Notice it's a linear equation. All you got to do is follow your steps. I don't see any fractions. I don't see any parentheses. I can't group anything on the left. Can't group anything on the right. So I'm going to go ahead and add 1 to both sides. I'm going to get my variable terms on one side, constant terms on the opposite side. And then I'm going to divide both sides by the number in front of my variable. A negative divided by negative is a positive. So x equals 1/5. So where I see the x in my table, I'm going to write 1/5. And then my point is 1/5, negative 2. That is the only way I could try to make this a little bit more difficult. All right, that's the only way. Other than that, it is just legit straightforward. So let's go ahead. Let's do the last one. So I have to erase all this stuff all over again. All right. So y equals negative 5. Put my parentheses, minus 1. We'll make our substitution of a 3. So y equals negative 5 times 3, which is negative 15 minus 1. And negative 15 minus 1 is negative 16. So when x equals 3, y equals negative 16, and that is the point 3, negative 16. So what I'd like you to do is use Desmos to verify that, yes, these are the correct solutions for the 3 arbitrary points that we decided to find. And that's going to be it for this video. So I hope you learned something about the rectangular coordinate system. I hope you learned about completing a table, finding solutions, understanding that when a point falls on the line, it's a solution. And when we come back, we'll talk about graphing. So taking the equation and actually graphing it ourselves. And then we're going to learn more about intercepts and slope of a line and everything like that. So I will talk to you in the next video. Bye.